Good morning everyone. I am Aniksha and today I am going to explain the topic hashing in data structure from theory to classroom heroics. In this presentation we will understand what hashing is, why it is important in computer science and how it helps us retrieve data extremely fast. By the end of this presentation you will understand how hashing allows computers to perform searches in constant time, which means big of one-time complexity. Why we need hashing? First, let us understand why hashing is needed. Imagine that we have a list containing 20,000 integers and we want to search for one specific number. If we use a linear search, the computer checks each element one by one. This can take around 0.48 seconds. However, if we use a hash table, the computer can find the element in about 0.001 seconds. This means hashing is approximately 500 times faster. Because of this speed, hashing is used in many real-world systems such as database indexing, password storage, caching systems, programming language dictionaries like HashMap in Java. The code idea: mapping anything to an index. The core idea of hashing is mapping data to an index in a table. This is done using something called a hash function. A hash function is written as h bracket k, where k is the key and each key gives the position in the hash table. The hash function converts a key from a very large universe into a number between 0 and m minus 1, where m is the size of the table. For example, consider a credit card number 1234567890123456 with extra digits 5678. Now we apply a hash function h of k equal to 5678 mod 101. The result is 23. So the data will be stored at index 23 in the hash table. Usually the table size m is chosen as a prime number. Using a prime number helps reduce pattern and decrease the chance of collision. When hashes collide, sometimes two different inputs produce the same hash value. This situation is called a collision. Collisions are very important in both data structure and cryptography. There are two famous real-world examples. First example, in 2004, researchers Wang and Yu broke the MD5 hash function by generating two different files with the same hash value. Second example, in 2017, Google demonstrated the shattered attack, where two completely different PDFs had the same SHA-1 hash. This example shows that even very strong hash function can eventually fail. Therefore, designing good hash function is an ongoing challenge. Classic numeric hash function, division method. One of the simplest hash function is called the division method. The formula is h of k equal to k mod m. Here k is the key, m is the table size. For example, if we choose m equal to 97, which is a prime number for key 3205, 3205 mod 97 is equal to 4. For the key 7148, 7148 mod 97 equal to 67. For key 2345, 2345 mod 97 equal to 17. So each keys get mapped to a different index. Using a prime table size reduces clustering, especially when numbers share common factors such as multiples of 10. Mid-square and folding methods. There are also other methods to generate hash values. The first method is called the mid-square method. Example, key equal to 7394. First we square the number 7394 squared equals to 54671,236. Then we take the middle digit, which are 671. Finally, we apply the modulo operation 671 mod 100 equal to 71. So the hash value is 71. Another method is the folding method. Example, key equal to 7148. We split the numbers 71 and 48. Then we add them. 71 plus 48 equal to 119. Ignoring the carry, we get 19. Another variation reverses the second part. 71 plus 84 equal to 155. So the hash becomes 55. Both of these techniques help distribute keys more evenly across the table. String hashing with Horner's rule. Hashing is also used for string. A common method uses Horner's rule, which helps calculate hashes efficiently. Let us take the word note. First we convert letters into numbers. N equal to 14, O equal to 15, T equal to 20, E equal to 5. Now we compute using Horner's rule. That is equal to 14 into 31 plus 15 into into 31 plus 20 into 31 plus 5 mod 101. Then the final hash value becomes 42. Honor sys is useful because it keeps intermediate values small and prevent overflow when working with long strings. This technique is actually used in Java's hashmap implementation. Collision resolution. Since collisions are unavoidable, we must handle them using collision resolution technique. Two common methods are chaining. In chaining, each slot in the table contains a linked list. If two key maps to the same index, they are stored in the list. Example, if bucket 3 already has the element A and we insert D, the list becomes A to D. Opening addressing. In open addressing, if a slot is occupied, we search for another empty slot. One method is linear dropping. The formula becomes h1 of k equal to h of k plus 1 mod m. If slot 3 is full, we try slot 4, then slot 5 and so on until we find an empty slide. Performance secret, load factor and birthday paradox. Two important concepts affect the performance of hash tables. First is the load factor represented by lambda. Load factor equal to n by m, where n is the number of element and m is the table size. For good performance, the load factor should be less than 0.75. In fact, Java hashmap use 0.75 as the default value. Second concept is the birthday paradox. The birthday paradox says that only 23 random seeds, there is about 50% chance of at least one collision. This shows that collision happens more frequently than we expect. Modern systems like Git switched from SHA-1 to SAT-256 which reduce collision probability dramatically. Takeaway and classroom challenges. To summarize the important points, first, always choose a prime number as the table size. Second, use a simple and fast hash function such as the division method. Third, always monitor the load factor and perform rehearsing when it becomes too high. Fourth, choose a good collision resolution technique such as chaining or open addressing. Finally, always test the hash function with different inputs to check for collision. As a challenge, students can try implementing their own hash map using memorhash, measure how the load factor affects performance, and observe collision in real datasets. Hashing is a powerful technique that makes data retrieval extremely fast. Because of hashing, many modern applications can work efficiently with massive amount of data.